Question 6. Could you explain the role of temperature in controlling outputs from large language models? Answer. Temperature is a hyperparameter that controls randomness in the token generation process of LLMs. Lower temperatures, such as 0.3, encourage the selection of highly probable tokens, resulting in predictable and consistent outputs. Conversely, higher temperatures, like 1.5, increase randomness by smoothing out token probability distributions, thereby generating more diverse and creative responses. A moderate temperature setting, around 0.8, often strikes a balance, facilitating both creativity and coherence, ideal for applications like storytelling or creative writing. Question 7. What is masked language modeling, and how does it benefit model pre-training? Answer. Masked language modeling, MLM, is a self-supervised training technique where tokens within a sequence are randomly hidden and the model predicts these masked tokens, based on surrounding context. A prominent example is the BERT model. MLM enhances the bidirectional contextual understanding of language, enabling LLMs to better grasp semantic relationships within texts. This method significantly improves performance on downstream tasks such as sentiment analysis, question answering, and language understanding. Question 8. Can you describe sequence-to-sequence models and discuss their typical applications? Answer. Sequence-to-sequence models transform one sequence into another, often differing in length. They typically comprise two components: an encoder, which processes the input sequence into an internal representation, and a decoder, which uses this representation to generate an output sequence. Sequence-to-sequence models are particularly useful for tasks involving variable length inputs and outputs, including machine translation, example translating English to Spanish, text summarization, and conversational AI applications such as chatbots. Question 9. What distinguishes autoregressive models from masked language models in LLM training? Answer. Autoregressive models, such as GPT, predict tokens sequentially, using previously generated tokens to guide subsequent predictions. This approach excels in text generation tasks like completion or creative writing. In contrast, masked language models, exemplified by BERT, predict tokens that are intentionally masked during training, leveraging bidirectional context. This makes them particularly effective for language comprehension tasks such as text classification or named entity recognition. Thus, autoregressive models primarily focus on text generation, whereas masked models emphasize comprehension and understanding. Question 10. Could you define embeddings and discuss their initialization in LLMs? Answer. Embeddings are dense vector representations of tokens, words or subwords, in a continuous high-dimensional space, capturing both semantic and syntactic meanings. Initially, embeddings can be randomly assigned or pre-trained using methods such as GloVe or Word2Vec. During training, these embeddings are fine-tuned, allowing them to evolve contextually to better reflect their usage in specific tasks. For instance, the embedding vector for dog might adjust based on context, such as being more strongly related to pet or animal, enhancing the model's semantic accuracy in subsequent processing tasks.